Some difference formula for tangent. The tangent of angle A plus angle B is equal to the tangent of angle A plus the tangent of angle B. Is that nice? Actually looks like what it's supposed to look like, doesn't it? That's the numerator. The denominator is 1 minus the tangent of A times the tangent of B. So tangent gives you a fraction, which shouldn't be all that surprising because, tangent is sine divided by cosine. That's how it works out. Suppose that it was minus here, it would be minus there, and it'd be plus down at the bottom. So it does switch sign. Are we okay with that? Okay, so for second hour and third hour, both, actually third hour doesn't really say anything at all. They're just very quiet. But first hour was very, very emphatic that this helped them. So I'm going to try to help you as best as I can. You don't have to write this down. You just need to follow along and try to come up with it as I do. Okay, what's the terminal point right here?
1, 0.
1, 0. And then I go to 30 degrees, and we have square root 3 over 2 and 1/2. Then I go to this spot, and we have our favorite, which is, everybody remembers that, right? And then we go to here, and we have, good. And at the top, we have
0, 1.
1. And I go over to this side, and don't they just repeat values? They're just happy to be negative for the x value. So I get that same thing as negative 1/2, and then positive root 3 over 2. And then I get that negative root 2 over 2 and root 2 over 2. I'm almost done, folks. Don't worry. And then I get negative root of 3 over 2 and positive 1/2. And then down here I get negative 1, 0. We good? Okay, so the deal with today is that we have values for tangent. But these are not the values for tangent, are they? Those are the x and y values which work for sine and cosine. So how do we use these values to come up with the tangent values? Divide y divided by x, correct? So if we take y divided by x, what do we get for this part? 0. So the tangent of 0 is 0. Not surprising, right? Let's look at the middle one. Root of 2 over 2 divided by the root of 2 over 2. That will produce 1. And then the tangent of 90, that would be 1 divided by 0, which is undefined. So, and then this would obviously be negative 1, and then this down here would be 0 as well, right? So those are not hard to think about or come up with, and usually people get those pretty quickly. Let's look at the other ones, and this is where you want to really lean in. So we've got 1/2 divided by the root of 3 over 2, and I don't divide by fractions, I multiply by the reciprocal. And when you do that, what are you going to get for your answer?
Square root of 3 over 3.
Square root of 3 over 3. So at the 30-degree angle, we get square root of 3 over 3. Okay, which means over here you get negative root of 3 over 3. So then what about this spot? Here we have the square root of 3 over 2 divided by 1/2. So I multiply by the reciprocal, and I get square root of 3, which over here I would have negative root of 3. So when you're choosing to work with values for tangent, the fact is that 0 works out nice, 45 works out nice, this 60-degree value works out nice. But everybody agree 30, that's not as nice of a number to work with. I want you to picture using the square root of 3 over 3 in context of this type of setup. If you plug in the square root of 3 over 3 for one of these spots, won't you get a complex fraction? Now, it still works out. You can use the square root of 3 over 3, but without a doubt, it becomes more challenging. So my encouragement to you guys is this. As you choose your tangent values, be smart about your choices. Don't choose the 30-degree angles, which would be 30, 150, 210, or 330. Don't work in that area. Instead, work in those areas. Does that make sense? Okay, good. We'll reference back to that. That should give you a little bit of an idea. Flip it to the next page. We just have these 2 problems. You'll have time to work. It says find the exact value of tangent of 19 pi over 12. This is where we pick up from yesterday. First, I want to take 19 pi over 12, which is a radian, and I want to convert it into degrees. How do I convert 19 pi over 12 into degrees? 180 over pi. You guys are super smart. You can pass the best. Good job. Way to go. Pi's cancel. I get 19 times 180 divided by 12, none other than 285 degrees. So I'm trying to determine the tangent of 285 degrees. I have all of the values written over here on the side. You don't need to write them. I'm just going to use those for our sake of practicing. I now need you and the people at your table or partner to come up with two sets of angles. I want two angles that add 285 and two angles that subtract 285. Come up with something, okay? Take 30 seconds, come up with two. Go.
40 and 45. This is smart.
That's the only reason I have that.
Recheck it. So,
Okay, two that add. What do you got?
45 and 240.
245 and 240. Good. Somebody else come up with a different one?
350 minus 30.
315, excuse me, 315 minus 30. Good. Anybody else? 330 minus 45. Good. 225 plus 60. Yeah? How about 135 plus 150? Looks like nobody got that one, huh? We good with that? Okay, so as we glance at this, the fact is that you can use any of these, come up with the same answer. If you want to avoid the complex fraction, then don't choose the ones that have a 30-degree reference angle, which is 30, 150, or 330, or 210. So I am not going to work with this one because it has a 30-degree angle. I'm not going to choose 330 because, again, the reference angle, meaning the angle formed against the x-axis, is 30 degrees. I'm going to avoid that. 135 and 150. 150 is a 30-degree angle against the x-axis. I'm going to avoid those. If you choose them, fine. Just it's going to take a little bit longer. I notice you guys like to be more efficient. Okay, without a doubt, I would describe your class as efficient. So, which one do you want to use? You want 240 or 225? Which set? It's up to you.
240.
Okay, we'll do the 240 option. There we go. So I know that then 285 is the tangent of 240 plus 45. And we just learned a formula that we can use, we can expand it to be able to come up with the exact value. And the formula says we just take the tangent of 240 plus the tangent of 45. So it's just like it looks in the numerator. And the denominator, do you remember how it starts? A 1 is it going to be plus or minus. Minus, it switches, and then you have that tangent of 240, and it's going to be times the tangent of 45. Okay? And a tangent of 45 is a nice, easy value. What's that one? That's 1. So we know tangent of 45 is 1. If you look at 240, remember 240 is down there, and that's going to be, in the third quadrant, is tangent positive or negative? Positive. And so it's positive square root of 3. Okay? So we have tangent of 240 is the square root of 3, plus tangent of 45 is 1, as you said. Now, this is where sometimes people make mistakes. I'm going to try to be intentional to show you what's happening here. But I have a 1 minus the tangent of 240, again, is the square root of 3, and I'm multiplying that by 1. So you have to multiply those two together. And I get the square root of 3 plus 1 over 1 minus the root of 3. Now, that's not my final answer, but it's a good start. Why can I not leave it in that form? Yeah, your denominator is not rational. The square root of 3 is an irrational number. I must rationalize the denominator. I'm going to do so by multiplying by. Root of 3 kind of works, but it kind of doesn't. The root of 3 will make that rational, but not that one.
1 plus the square root of 3.
What do we call that? So is a C? We use it in Spanish? The conjugate. Yeah, we multiply by the conjugate. We multiply by 1 plus the root of 3 and 1 plus the root of 3. So I look at the bottom, I choose the conjugate for the bottom, and I multiply top and bottom by the same because the top and bottom just makes that expression 1. So I'm not changing the value of the fraction, I'm just rewriting it. So as we multiply this out, good thing you guys are really good at math and you can multiply these things out. We'll do the top first. I get the root of 3 times 1, which is the root of 3. I get the root of 3 times the root of 3, which is 3. I get 1 times 1, which is 1. I get 1 times the root of 3, which is the root of 3. I divide that all by the denominator. And notice that when I multiply out the conjugate, the beauty of the conjugate is what happens to the middles. They cancel. So that's, it's the beauty of this. We just multiply the front and we get 1. And then I have negative root of 3 times positive root of 3, which is just minus 3. Excellent. So in the top, we have 3 plus 1, which is 4. And then the root of 3 plus the root of 3 is 2 roots of 3. And that all sits over negative 2. Can I divide 4 and 2 by negative 2? I sure can. 4 divided by negative 2 is negative 2. And 2 divided by negative 2 is negative 1. And so the exact value for the tangent of 285 degrees is, in fact, negative 2 minus the root of 3. That's the exact value. Now, everybody is ready at this point to set the pencil down and wash your hands. And this is what I need to get you in the frame of thinking, because this is going to help you when you get to the ACT and other pieces. We haven't even checked to see if that's reasonable. Is that answer positive or negative?
Negative.
It's negative. Which quadrant is 285 degrees in?
Fourth.
The fourth quadrant. Is tangent positive or negative in the fourth?
Negative.
It's negative. And in fact, as I go to check this solution, I'm saying negative 2 minus the root of 3. That would be like, say, like negative 3.5 or something like that. Everybody agreed? I said that tangent a long time ago was like slope. If you drew 285 degrees, does that look like a line that would have a slope that was pretty steep, like negative 3.5? Yeah, it does. See all the connections you can build together? If your line looked like this, you'd be like, well, wait a minute, that's not that steep of a slope. I shouldn't come up with something that big. You know what I mean? So it kind of helps you check the reasonableness. Okay, we move to our last problem. Pair and share with the person next to you. How do you feel about geometry proofs? Go, share.
You have to like write down every single step you do.
Are they coming back?
Still about the same.
Oh, okay.
Okay, so anybody need to get out some like frustration that they had regarding geometry proofs?
You just did.
Got it? Okay, you've kind of gotten it out of your system. Some people don't like them, but you need to really kind of get rid of that thought that all proofs are necessarily bad. This works out pretty well. And the nice thing about proofs is you move forward in mathematics. Geometry proofs are one deal, but there's a lot of other types of proofs. And we are going to actually prove a co-function identity. So if you look at your notes back here, if you just flip back here real quick, notice we've been working in the sum and difference category, haven't we? There are also some what we call co-function identities. This is really a short way of saying, for example, do you guys remember that when we graphed sine and cosine, that they pretty much looked the same, didn't they? They're just like you could shift a graph and make a sine function look like a cosine function. That's what these co-function identities are saying. We are going to prove this one right here, and that the tangent of pi over 2 minus a is the same as the cotangent graph. Okay, it's not going to be any big deal. So what we are given in this problem is the answer, and that's what you have to appreciate about a proof, is that you are given the answer. The answer is cotangent. All you need to do is just make a logical step in between. That's it. So let's make the logical steps, and you guys will help me do that. Notice it says tangent of pi over 2 minus u. Now, looking at this, you may say, well, I'm going to use the tangent of pi over 2, and I'm going to use the tangent of u. And in fact, we won't. And here's why. What is the tangent of pi over 2?
Undefined.
Undefined, 90 degrees. So see how that does not help us? We don't want an undefined result. So instead of that, we are going to choose sine of pi over 2. Well, I'm sorry. Mr. Gantz, get your crap together. Okay. Tangent of pi over 2 minus u is equal to the sine of pi over 2 minus u divided by the cosine of pi over 2 minus u. That is my first step of the proof. I always must start with the beginning statement, this tangent of pi over 2 minus u, and I will then end with the cotangent of u. Is everybody okay with that first step? That's obvious, right? Nobody can here dispute that tangent is sine over cosine. So now we do our next step. I would like to expand sine of pi over 2 minus u and expand cosine of pi over 2 minus u. Who can tell me from yesterday, how does sine of pi over 2 minus u expand? Sine of pi over 2 times cosine of u plus or minus cosine of pi over 2
times
sine of u. Good. That's how we expand sine. That's related to exactly what we did yesterday. You guys all know that because you finished your homework. Good job. And so then we go to the bottom and we expand cosine of pi over 2 minus u. It will start as the cosine of pi over 2 times the cosine of u plus or minus plus sine of pi over 2 times sine of u. Now, right now it looks bulky and you're like, oh, Mr. Gens, you're not helping me kind of restore my faith that proofs can be good. But trust me, it'll all come together here real soon. You just need to decide with the people next to you, what is the sine of pi over 2 and what's the cosine of pi over 2 and why? Talk, 20 seconds, go.
Yes.
Sine is y, right?
Yes.
So then that's
5, 4, 3, 2, 1. Sine of pi over 2. That would be the y value right here, which is 1. Very good. And the cosine would be 0. So look at what I'm going to do. As I know the sine of pi over 2 is 1 and the cosine of pi over 2 is 0, I can place 1 in for sine of pi over 2. And I can place 0 in for cosine of pi over 2. And one thing you'll start to love when you do proofs is anytime you come up with 1s and 0s, that's really a beautiful thing. Because 0 times anything is 0. So watch here what you get. If sine of pi over 2 is 1, then what does this piece become right here?
Cosine of u.
So I have cosine of u. And this piece is 0 times sine of u. So what is this? So this all just disappears, doesn't it? Like you just have cosine, that's it. Then look at the bottom. You've got 0 times cosine, which is going to be 0. And then you have 1 times sine, which is just sine. What's cosine over sine?
Cotangent.
Is that what we were supposed to come up with? Absolutely. That's the proof. Some people may say that that's your answer on. The entire piece is your answer. Now you get this wonderful moment where you now have graduated to a point where you get to decide how you end your proofs. And there's really 3 accepted ways, and you can make up your own if you want because we're just going to have fun. But a lot of times if you end a proof in mathematics, you write the letters QED. It's an acronym for, it's in Latin, and it's an acronym for that which was to be demonstrated has now been shown. Okay, so people just for short write QED. Some people would like to do something different. Every once in a while, if you look at a text, you'll see people end their proof by drawing a little box. Just the box means I'm done. You know what I mean? And sometimes people have fun with that and they actually like put a check mark in it or something like that. I suppose. They don't do that in textbooks, but if you want to draw a box. My one of my professors in college, probably the smartest man I ever encountered, Professor Zorn, he was taking us through a theory course, and he was trying to figure out how to end his proof. He had both a doctorate in mathematics as well as English. So he would first go through all our proofs to make sure they were mathematically correct, and then he would go through to make sure they were grammatically correct. You actually got both a math credit and an English credit by taking the class. And I remember one day he's standing at the board. He's trying to figure out how to end the proof. And he's not writing QED. He's not writing the box. That's what he did every time. And he's like, and after like pausing for 10 seconds, finally he writes this incredible word. He goes, and he writes down and walks away. So I don't know. I guess I learned from that you could just end the proof however you want. So just a moment where you say, yes, I've crossed that path. Think of your homework. Professor Zorn, you know that a person's smart when the book that you're using was written by the person standing in front of you. That's where there's a little humility. So you are now ready to do problems 4 and 5 and 8. Okay, 4, 5, and 8. And then if you flip to the back side, you'll be able to finish off those couple things as well. Okay. So I told you the nice thing is you always know which formulas to use. The challenging thing is that it doesn't make everything easy. You do have about 17 minutes, 18 minutes to be able to work on this. I do have the answer key posted online. I also have it posted up in front of class. I have to sub for the next class period.